if a and b are integers and both of them not 0, then Bezout's identity says the following, that there exists integers s and t such that the GCD of a and b is equal to sa plus tb. So in other words, the greatest common divisor can always be written as an integer combination of the two numbers, right? For example, we saw in the GCD video, we saw that GCD of 252 and 198 is equal to 18. And so this is saying that you can write 18 as an integer combination, so only with integers. It's some integer times 252 plus some integer times 198. And indeed, one can check that 18 is equal to 252 times 4 plus 198 times minus 5. So these are the two integers. So this would be the s and the t here. But how do we find these integers? How can we do that? And one way to do that is through what's known as the extended Euclidean algorithm, which again, you can go and read the whole algorithm here or in the slides. But I think the easiest thing is just to see an example. So let's say that we want to do this. We want to find how can we write this equation here, GCD of this equal to a linear combination of this. So the first step is going to be actually doing the Euclidean algorithm, which will actually give you also the GCD. So we first do the Euclidean algorithm. And so how did we do that again? So we take the larger number and divide it by the smallest one. So 252 is going to be 198 times 1 plus 54. Then we go and divide this number here by this remainder. So now 198 is going to be 54 times 3 plus 36. And then we go again and divide this number here by this remainder. So now 54 is going to be equal to 36 times 1 plus 18. And then we go and divide this number by this remainder. And so 36 is going to be 18 times 2 plus 0. And if we look at the sequence of the remainders, it's the last remainder before the 0. So the GCD is 18. So from here, we get that the GCD of 252 and 198 is equal to 18. Now, to find s and t, what we're going to do is something called back substitution. So let me rewrite this. So step 2, back substitution. And so how do we do that? Well, we go to this equation here, the equation where we got the 18 from. And what we're going to do is we're going to express because at the end of the day, we want to do 18 is equal to some combination of these two numbers, which are these two numbers over here, right? So what we're going to do is we come back to this equation and we write 18 in terms of this equation here. So 18, let me do a different color. So then 18 is going to be equal to 54 minus 36. Okay. And so for this, we used this equation. But now, for this 36 here, so this 36 was the remainder here, and now we're going to replace this 36 with 198 minus 54. So this will be equal to the 198, so this is going to be 54 minus 198 minus 54 times 3, right? And we can write this out as 4 times, so this will be 4 times 54, right? So it's 54 minus 3 times 54, so 4 times 54 minus 198. But now we can go and replace this 54 here in this equation over here, right? Oh, sorry, in this equation over here. So the 54, you can write it as 252 minus 198. So if we do that, so then this will be equal to 4 times, so the 54 is 252 minus 198 times 1 minus 198. And so if we write this out, so this is going to be 4 times 252, and then we're going to have minus 4 198 minus 198 is going to give us minus 5 times 198, which means that we can just take our s equal to 4 and our t equal to minus 5, and then our GCD, our 18, is equal to 4 times 252 plus minus 5 times 198. So let's do a quick recap. So we want to be able to solve this. We want to be able to write the GCD of two numbers as a combination of these two numbers, as an integer combination of two numbers. So step 1, we do the Euclidean algorithm. So we take the larger number, divide by the smaller, and so that gets it started. Then you divide this number by the remainder, and you get this. Then you divide this number by the remainder, and you get this equation. Now you get this number and divide by the remainder, you get this equation. When you reach a 0, the previous equation, this 18, is going to be your GCD. And now we want to find S and T. Well, if we have these equations here, so let's go to the equation where we found the 18. We're going to write the 18 as 54 minus 36. That's what we do here. Then we go to the next equation. And now this 36, we're going to write as 198 minus 3 times 54. So it's this part here. Okay. And you can simplify it. And now we go to this equation. And we write out the 54 as 252 and 198, and we replace. And you can see that when you're doing all these replacements, what you will end up with is an equation that depends only on 252 and 198. And this will give us exactly what we were looking for. So we'll be able to find our S and T.